Hello class, welcome to 6.1, which is a continuation of the previous video. Here we're going to talk about graphing sine and cosine functions. And there are two ways to graph this. One is to use your transformation idea, those techniques, and move them and shift them and stretch them and get your graph. The technique I'm going to share here would be a traditional graphing where you have the x and y columns and get your coordinates and you plot them and you get your graph. So this is traditional, which means you could apply it in any condition that the function appears in. It can be a little time consuming just because you are doing these things systematically. But the benefit of that is you have some inbuilt tests or patterns that you can see to make sure that you are moving in the right track, right? So let's begin with some simple functions and move on to a full-fledged sinusoidal function. Okay. As a warm-up, let's begin with let's say graph y equals 3 sine x. Okay. In the previous video, we graphed sine x, so here it's 3 sine x. So it's not a big stretch, but you can definitely see that we're going to do it systematically. Okay. So we have step 1. So I'm going to talk about steps, okay? That way it is easy for us to follow the order. Step 1 is first let's find all the A, B, C, D, all that stuff, right? Now, it's always good to have the full form, okay? Y equals A sine. This is a sine function, so I'm just going to stick to sine plus D. Okay. So based on that format, do we have an A? That's what we're looking for. Yes, A is this position 3. So A, we have 3. You know what? I'm going to kind of change this question slightly so that I can use a negative function, because I could teach an additional idea here. So sorry about that. I'm going to change the function to y equals negative 2 sine x. So let's stick to A being negative 2. Okay. So now that gives us an idea as to what A really means. A here means amplitude, but A is coming out as negative 2. But remember, amplitude is how high or how low it goes. So negative 2 can give you, the negative amplitude can give you additional information. We'll look at that in the end. But ultimately speaking, absolute value of A, which is positive 2, is the amplitude in this case, thereby giving you the maximum value of Y. So then I will say this is the maximum value, value of Y is 2, and the minimum, the lowest it can go, the graph, right, is negative 2. So we got that information. Then let's look at B. In the place of B, there is really no problem there because your B is just 1, right? So B is in this position. Anything, the coefficient of x is your B. So B is 1. There is no C, so C is 0, right? There is no position for C. And D is also 0. So things are good here, okay? And the reason we need B is to find the period, okay? So the period is 2 pi over B. That's 2 pi over 1, which is basically 2 pi. So there was no change in your period. Period is every 2 pi units, you have the cycle repeating. Okay, so we got all those things. Now let's move to step 2. So here we are, if you recall, let me take you here. You recall here, we, let's look at the pink graph, okay? The pink graph, I used only 5 points to get my wave pattern. The purple part of it is also 5 points. The blue point, 5 points. But when we begin to learn about this sketching, then we used numerous points. But we were able to see that this pattern can be, once we recognize the pattern, we could achieve this pattern with 5 points. So in step 2, our job is to come up with those key points, find the key angles, key points. For that, there is a kind of a trick, okay? So we first start by using this, what do I say? This is more like a trick. Okay? We use period over 4. Again, this trick is mathematically sound. I call it trick because it just helps you to get started on getting your points. All right, so what is our period? Our period from step 1 was 2 pi. 2 pi over 4. So this comes down to pi over 2, right? So period over 4 comes down to pi over 2. All right. Then we want to get 5 key points, right? Let me just write that out there too. 5 points. So we want, just for convenience, I'm going to call, start off as x1, x2, x3, x4, and x5. So we know that these are the x's, and then you have the corresponding y column. So x1 is always from where your cycle begins. Your cycle begins from your phase shift, right? So your phase shift kind of tells you where to begin the cycle. So the cycle starts at phase shift. So let's recall, what is phase shift? So I go back to step 2, and I know that phase shift comes from C over B. Now in our case, C is 0 over 1, so there was no phase shift. So phase shift is 0. Therefore, the cycle starts at phase shift means here that the cycle starts at 0. Okay? So then your x1 is 0. Okay? Now we will start using, from the starting point, we will be able to generate the other x values. So this is x1. Okay? So your x2 stays the same color. X2 will be x1 plus the period over 4. I'll just put that in general format here so you can see that. Right, the answer you got from period over 4, that's what you keep, that's what you keep using to generate your x2. So x2 here would be x1, which is 0, plus the period over 4, which is pi over 2, which is ultimately pi over 2. Then we go to x3. x3 is this previous point, x2, plus the period over 4. See how the pattern is beginning to form. So my x2 is pi over 2, plus the period over 4 is also pi over 2. That is 2 pi over 2, right? Which is simply pi. x3 is, x4, right? x4 is x3 plus period over 4. And x3 was pi plus pi over 2, right? Period over 4. What I would like to do is, if you see here, I kept it as 2 pi over 2, and then I reduced it as a pi, but you see the 2 pi over 2. I personally like to keep that format, 2 pi over 2, because I don't have to worry about LCD, because then they will have the same denominator, right? So that will be 3 pi over 2, because you simply add the numerators. And the last point, key point, out of the 5, that is the 5th one, that will be x4 plus period over 4. That comes out to be this 3 pi over 2 plus the pi over 2, which will be 4 pi over 2, which is again equal to, that reduces to 2 pi. But I would like you to pay attention to this format, because what we're trying to do is, this is your first value, right? 1. Then it's pi over 2. Keep this, not the pi. Don't look at the reduced version. Look at it before you could reduce them, so that they all have the same denominator. That's what I'm trying to see. If you line them up with their same denominator, you can see the pattern more clearly. It's 0, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2. You can see that it's jumping by each time by a 1, right? So 1, 2, the numerator, 1, 2, 3, 4. And that is really interesting, because you know that you've done the calculation right. That setup really helps you with that. Once you've got this, you're pretty much all set, because now you're ready to draw your table. What step was this? This was step 2, right? So step 3, find the y values for the key points. This is basically your table, okay? And so I have the x column. I'm going to kind of create more room for, because we got the x's, we have no problem with the x's. We need more room to do the computation for the y, because the y is the actual function. And then I'm creating another column so that I'll have the x comma y put in there. So the y is -2 sine x, right? That was a given function. And then this will be the x comma y to help us plot when we get back to the grid. All right, so let's line up our x's. The first one was 0, right? So I'm going to compute it here. So I put -2 sine 0. You need your unit circle for this, right? Which is -2 times sine 0 is 0, which is equal to 0. We'll kind of compile the last column in the end. Now look at our x values. It's really, if you come back here, if you use the reduced version, you're actually looking at your key 5 points, right? 0, pi over 2 pi, 3 pi over 2, 2 pi. So for computation purposes, we'd like, because our unit circle, let me take you there. Our unit circle has 0, pi over 2. It doesn't, we don't write this pi over 2 as 2 pi over 4, or the pi as 4 pi over 4. We don't do that, but we can see that, you know, we like to see our unit circle in the reduced form. So that's the reason why we would keep the unreduced version to check the pattern, but then when you're computing, keep the reduced form. So then the next one would be pi over 2, then pi. 3 pi over 2 and 2 pi. So I hope you can see how I'm switching. So and feel free to, you know, do that. So this will be pi over 2. Go to your unit circle, -2 times sine pi over 2. Sine pi over 2 is a 1, so that comes out as -2. -2 times sine. I'm plugging in the place of x with these angles. Sine pi is 0, so that's a 0. -2 sine 3 pi over 2. -2 times 3 pi over 2 has a -1, so that makes it a +2. And -2 sine 2 pi is -2 times 0, which is 0. And so we have 0, 0, pi over 2 comma -2, pi comma 0, 3 pi over 2 comma 2, 2 pi comma 0. Yeah. Now take all these points and you can plug them in, and you can already see that your y values, that's another place for you to check. So let's quickly make note of that. You know that your, I have to take you here quickly. So you know that when we did the, let's look at the pink graph, okay, just the pink period. You know that we went from 0, then 1, 0, -1, and then 0. If you look at the green graph, which is your cosine, even there you saw this pattern. It was 1, 0, -1, 0, 1. So all along, your numbers are fluctuating. If you choose those particular angles, the numbers fluctuate between 0, the amplitude on the high point, amplitude on the low point. And these three are the three values that keep repeating, right? In our case, our amplitude was 2, or rather -2. So your fluctuation is between 0, -2, and 2. And you see that pattern repeating. And that's good to know. You didn't have any new number, or the 2 didn't become something else. That means something is off. And so that also is the inbuilt check that you can see if things are falling in place. So there was an inbuilt check with step 2 when you generated those x values, x1, x2, x3, x4, x5, and that pattern. And then in step 3, your y values that came out of these x values also show a pattern. So now all things are good. Now it's time for us to kind of graph them and connect it, okay? So I'll just come back here and say step 4. Plot the points on the graph. When I say graph, I mean the grid. Okay. So I'll just say plot the points and graph. That'll be better. Graph a smooth curve, because you're not connecting it with a ruler. You're trying to connect this freehand as a smooth curve. Graph a cycle, or I can say graph a period. As a smooth curve. Now, sometimes there might be a step 5, which would be, in response to additional information. So if they wanted your angles to be in a particular range, then you would just make sure that you graph them in that particular range. If, like for instance, you could have, maybe I'll just bring that in as soon as I'm done with this. So step 5 could be that, say, what shall we say? Let's say your angles, right? Your x, that's your angle. Let's say we said your angles must be from -pi to 3 pi. Then you are going to do step 4, which is graphing one period. Okay, graph a period, graph one period. And then if your period is within this limit, then you're going to extend it so that it runs from -pi to 3 pi. Okay? Let's try and do that, to this problem. I'm going to come here and, okay, I need a fresh page, so let me get that. Okay, my page is fresh. Now let's go ahead and begin graphing. So the coordinates, I'm looking at these coordinates here, 0, 0, pi over 2, -2, pi, comma 0, 3 pi over 2, 2. That's what I'm trying to graph here. Okay. All right, 0, 0, pi over 2 and -2. So pi over 2 and -2. So it's going down actually. The sine function, last time we usually see our sine function going up like this and then coming down. But remember, there was a reason why your amplitude was a -2 sine x, right? The amplitude was -2. That -2 means there was a reflection that took place. So what went up, what should have gone up, is actually reflected. So it is actually first going down before it goes up. So that is lining up. Then we have pi and 0, have that. 3 pi over 2 and 2. 3 pi over 2 goes all the way up to a 2. And then we land back at 0 on pi, or 2 pi. As you can see, this time the graph is going to be stretched vertically because the amplitude was not the standard 1 or -1, right? Not going up and down 1 or -1, but it's going up or down -2 and 2. So connect these. It's a smooth curve. Okay, so that's my y equals -2 sine x. And that -2 means that it's going down -2 first before it goes up. And because I kind of introduced a step 5 just for additional work here. So our step 5 says you need to stretch it to from negative pi to 3 pi, negative pi to 3 pi. So I need to get a point here, and then 3 pi. Unfortunately, I don't have that here, so I should have used this one. Okay, no problem. We'll graph it again. So we have 0, and then we had pi over 2 with a negative 2. So see, it's not really that bad to graph this one because those 5 points are really nice points. You are not trying to eyeball the coordinates. They are right, right in the intersection of those boxes. So you have that ability. So now let's go ahead and connect our graphs. Okay, and this is one period, y equals negative, y equals negative 2 sine x. Okay, let's stretch it all the way to 3 pi on this side. So now I'm just going to use symmetry here. Okay, and to kind of show that extension, I'm just going to use a different color just for us to see. So 5 pi over 2 is going to come down here, and then 3 pi is going to come up here. Okay, and this side they wanted it to go up to negative pi. So here, negative pi over 2 would go all the way up here, and then negative pi would be that. So your negative pi to 3 pi is your step 5, but the orange part is just your one period. That is step 4. So if the question does not give you the range of x values, your angles, then you will just stop with the orange part. If it asks for extended intervals, then extend your graph as desired. All right. Okay. So let's go to the next problem. Okay, I have the next problem here. Graph y equals 3 sine 2x. Okay, we're slowly warming up. Okay, the next one would be the big one. So we got this. Let's try to move through this quickly because we saw these steps elaborately in the previous example. So step 1, get your a. Again, it's always a good idea to have y equals, this is again sine. We're going to do sine and then we'll do cosine. So we have a sine bx minus c plus d. That's your format. So your a is 3, it's positive 3. So from the past experience, you know, this is going to go up first because a is positive 3. Nevertheless, absolute value of a is 3, which tells you that that's your maximum height up and down, right? B, do we have a B? Yes, we actually have a B. There's a coefficient for x, that is your B. Okay. C, there is no C. D, there is no D. And again, as I mentioned, you need the B to find your period and also to find your phase shift. So period is 2 pi over B. Let's remember that. And 2 pi over 2, B is 2. So that means my period is pi. So what was repeating every 2 pi is repeating every pi, right? So there'll be 2 repetitions now within 2 pi because it's repeating every pi. Can you see that? It's kind of shrunk. It's going to be, kind of compressed horizontally so that you get this whole thing from 0 to pi instead of previously 0 to 2 pi. Okay, let's get that off. Then we have the phase shift, which is C over B. Do we have a C? Well, there is no C position here, right? There's only a 2x, there's only bx, there is no minus C. That's 0 over 2, which is 0, so no phase shift. Step 2, you need to get your key points, right? For that, we need this information, which is period over 4. Our period was pi, so pi over 4 is our period over 4. We need this to generate the points. X1 is always your phase shift. And our phase shift again in this problem is 0. X2 is this 0, phase X1 plus pi over 4, which is pi over 4. X3 is X2 plus period over 4. So that's pi over 4 plus the period over 4, which is pi over 4. We found that. That's going to be 2 pi over 4. In the reduced form, this will be pi over 2. But remember, we said we want to maintain the same denominator to see a pattern. X4 will be X3, which is 2 pi over 4, plus the pi over 4. That's 3 pi over 4. And X5 will be this 3 pi over 4, the previous point, plus the pi over 4, which is 4 pi over 4. And reduce that to get your pi. And quickly look at it, and you see that it's 0 through pi. Okay. Okay. And then we are now ready for step 3, which is the table. Mark the X. And I write my y here as 3, what was it, 3 sine 2x. And this will be the x comma y column. Okay. So we got these points. This time for the computation, I'm going to use the reduced version. So 0, pi over 4, pi over 2. So let's do that. Use a different color. If you looked at this, right, it's 0 to pi. This is basically your upper half of the circle, right? So 0, pi over 4, pi over 2, take you here. So then you're looking at, where are we? 0, pi over 4, pi over 2, 3 pi over 4, and pi. You can see those are the 5 points we're looking in our graph. So get that off and take us back here. Pi over 2, 3 pi over 4, and pi. Okay, so 3 sine 2x. In the place of x, we plug in 0, which is 3 sine 0, which gives us, again, 3 times 0 is 0. The next one, it's 3 sine 2 times pi over 4, which is 3 times sine, cancel the 2 and the 4, right? That's pi over 2. 3 times sine pi over 2 is 1, which is 3. This is all coming from the unit circle. You're already beginning to see that you have the positive 3, which was your amplitude, coming up. Okay. Then we have 3 sine 2 times pi over 2, which is 3 sine pi. Right? The 2's cancel off. And sine pi is a 0, so that's going to be 0. 3 sine 2 times 3 pi over 4. Once again, the 2 and the 4 will cancel off, giving us 3 sine 3 pi over 2. 3 pi over 2 is a negative 1. Sine 3 pi over 2 is negative 1, which is negative 3. And lastly, sine 2 times pi, which is 3 sine 2 pi. And you know sine 2 pi is 0. And that gives us a 0. So if we write the coordinates, 0, 0, pi over 4, 3, pi over 2, 0, and 3 pi over 4, negative 3, and lastly pi, 0. Then we'll go to the graph screen to go ahead and graph it. So here we come, 0, 0, pi over 4 and 3, pi over 2, 0. You see how tall it's going, how stretched it is? Then it's 3 pi over 4 and a negative 3 all the way down here. And pi would be 0. So we would have ideally gone up to 2 pi here, but if you can see, this is half of that. So it's going to be skinny. All right. And just to give us a to give us step 5, what if I said your x must be between 0 and 2 pi? So if your x is between 0 and 2 pi, then let's stretch this. 5 pi over 4 would go all the way up here, right? 3 pi over 2 would be 0. 7 pi over 4 would come down here. And then there will be the 2 pi. Remember we said it's like having two rotations within the 2 pi. So then you have so that's going all the way from 0 to 2 pi as they expected from us. Okay. Now always label your graph because this is your y equals 3 sine 2x. Okay. And then we come back to the next problem. So let's take a nice complicated one. Graph y equals 4 sine 2x minus 2 pi over 3. So this is the third sine example, then we'll do a cosine example as well. Okay. Well, you can see as it is that there is really no big difference. You just have different points now, and your cosine, you expect it to be like a V if it is not reflected. If it's reflected, then it's like an inverted V. Anyways, we'll just get going with this. Y is A sine bx minus c plus d. Again, d, if you get a d, you will just do all these things and just move up or down by that many points. If d was 3, get your graph your function without the d, and then you can move it up 3 units. If d is -7, graph it without the d, and then move it down 7 units. So d is really not a problem, but it's a question of moving, shifting up and down, so you don't have to worry too much about if the d appears. A is 4. Absolute value of A is absolute value of 4, which is 4. So it's going to go up and down 4. It's going to go up first. You can see that. B is 2 because it's a coefficient of x. In this case, we have C. C is it's in the minus form, so that is good because you have to maintain that minus. Okay, must have minus. If there is no minus, then if it is a plus there, then you have to see it as double minus. There are 2 minuses, a minus and a minus C. In this case, all good. So C is just the 2 pi over 3. So let's remember that. C is just the 2 pi over 3. Okay, and then D is 0 here. Period is 2 pi over B, and 2 pi over 2, which is pi, very similar to the previous one. Okay, and then we have phase shift, which is C over, fix that, C over B. That's 2 pi over 3 over 2, because B is 2. So if you just kind of spread this out, this is 2 pi over 3 times 1 over 2, because you still have a 2 in the denominator. So you flip the 2, so that becomes 1 over 2. Simplify this, this becomes pi over 3. Okay, we got that. Then we have step 2. Step 2 is period over 4 first. The period is pi over 4, very, very similar to the previous one. However, your x1 is your phase shift. And in this case, we do have a phase shift. So the cycle starts at pi over 3. We're not starting at the traditional 0 we've had. We're starting at pi over 3. All right, x2 will be this pi over 3 plus the period over 4, which is pi over 4. This requires little LCD here, right? So you have 3 and the 4, so the LCD is 12. So adjust your fraction. Okay. I'll just show the first one, but you know, technically you should be familiar with this already. So the first one would be when you multiply up and down by 4. Let me just show that here, 4 pi over 12. Then adjust the second fraction, multiply up and down by 3. That's 3 pi over 12, which adds up to 7 pi over 12. Okay. X3 would be this 7 pi over 12 from x2 plus the pi over 4. In both these cases, LCD is 12, so it's enough that you adjusted just the second term. So multiply up and down by 3, that's going to be 3 pi over 12, which is 10 pi over 12. Okay. This again, we could go ahead and simplify, but again, I want to leave it the way it is. X4 is 10 pi over 12 plus pi over 4, 10 pi over 12 plus 3 pi over 12. In fact, if you wanted to, you could convert the period over 4 itself as 3 pi over 12, because you see that you're going to need that in every step. So that's another way to quicken your process. 13 pi over 12, and x5 is 13 pi over 12 plus pi over 4, 13 pi over 12 plus 3 pi over 12, 16 pi over 12. Now I'd like you to check your pattern. This pi over 3. Again, for pattern, notice that all other key points are all in terms of 12. So I want to convert this also to 12. Okay. So to change this to a 12, you need to multiply up and down by 4. So that will be a 4 pi over 12. Okay. Now I want you to see that we start at 4 pi over 12, then 7 pi over 12, 10 pi over 12, 13, 16 pi over 12. So what is the common width? How are they jumping? The numerator is jumping by 3, right? 4 plus 3, 7, 7 plus 3, 10, 10 plus 3, 13, 13 plus 3, 16. You see that uniform equal width from one point to the other, you know you got it right. Okay? Now it's time to go for step 3. So, because it's kind of a long expression, give more room to calculate in step 3. Make it nice and broad. Y equals 4 sine 2x minus 2 pi over 3. And this will be x comma 1. The first one was pi over 3. You can use the pi over 3. You could use the 3 pi over 12. I'm sorry, what was it? 4 pi over 12, sorry. So that's 4 times sine x is pi over 3. 4 sine 2 pi over 3 minus 2 pi over 3, which is 4 sine 0, because it's the same, right? They cancel off. Sine 0 is 0, 0. Next we go to 7 pi over 12. 4 sine 2 times 7 pi over 12 minus 2 pi over 3. This is going to, there's always this 2 there because it's part of the given function. And each time if you go back to your x's, each of them have the denominator 12. So each time it's going to have that 2 and the 12 canceling off and giving you a 6. Okay. That means each time I'll have this denominator 6, I'll have to adjust this denominator 3 here with a 2 up and down. So when I anticipate these things, I always try to reduce a step there because you are taking care of the calculation. So then you have sine 7 pi over 6 minus 4 pi over 6. Okay. So then this expression, I'm going to, each time in future, I'm going to rewrite the 2 pi over 3 as 4 pi over 6. They're equivalent, right? So I'm going to keep that and see if that will help me save some steps and quicken my calculation. So that will be 4 sine 3 pi over 6, 7 pi minus 4 pi, 3 pi over 6, which is pi over 2. 4 times sine pi over 2. You don't want too many steps, so try to do some of them, simple ones mentally. Sine pi over 2 is 90 degrees, so that's going to be a 4. Okay. The next angle was 10 pi over 12. Actually, I can add 3 each time. I don't have to scroll up to see it, right, because of that pattern. So sine, again, I know the 2 and the 12 will cancel off, so I'm just going to do 10 pi over 6 minus 4 pi over 6. Yeah? Because I know the denominator will be a 6. If you're not convinced, you can go ahead and simplify it because the 2 and the 10 pi over 12, the 2 and the 12 will cancel. And this I've already decided to use 4 pi over 6. All right, 4 sine 6 pi over 6 is what this becomes. And the 6 and the 6 go away. That makes it 4 times sine pi. Sine pi is a 0, so we get a 0. 4 times 0 is 0. Let's stretch this some more. So add another 3, you get 13 pi over 12. 4 sine 13 pi over 6 minus 4 pi over 6. Yeah. 13 minus 4 is 9 pi over 6. And you have 3 here and 2 here. So 3 pi over 2, that's the 270 degree mark. And that would be 4 times a negative 1, which is negative 4. And the last point is 16 pi, another 3, right? 16 pi over 12. 4 sine 16 pi over 6 minus 4 pi over 6. That's going to be 12 pi over 6, 16 minus 4. And the 6 and the 12 will make it a sine 2 pi, sine 2 pi. Oops, there is a 4 in front of it, sorry. So 4 times sine 2 pi is a 0, which is 0. Now I'll come back here and collect all these coordinates. Pi over 3, comma 0. 7 pi over 3, comma 4. Again, look at your y values. You're looking for patterns all the time. So it's 0, 4, 0, negative 4, 0. So that's really, really promising. I'll put a 3 here. It should be a 12. I'm not sure where I got the 3 from. 13 pi over 12, comma negative 4. And lastly, 16 pi over 12, comma 0. Okay, all good. Now we need to go back and use the grid. Now I'm not going to use the same grid that I used previously because that was specifically for pi over 4 and pi over 2 and so on. This is different because now we have the denominator as 12. So I want to kind of show you how you can build your own grid and not just depend on these pre-built grid. So we'll look at the graphing part of it right now. So what I have here is I've given more room for the x-axis, and I know that my y-axis, if you look at the coordinates, it's going to go as high as 4 and as low as -4, right? Your y values are that. Your x values are, again, this pi over 3, I'd like to rewrite it here as 4 pi over 12, okay? So it's 4 pi over 12, 7 pi over 12, and that's what I'm trying to mark. So if I come back to my grid, now my grid has to have a pattern. We already see that pattern in the y, in the x angles, but you can't just start at 4 pi over 12 and then jump to 7 pi over 12, right? You have to start with that recurring pattern. So all I'm seeing is that everywhere it's over a 12. So I could have this as pi over 12, 2 pi over 12, 3 pi over 12. Can you see that? And that could be my scale. So just to prevent it from being too crowded, I'm keeping that same scale, but I'm just going to be marking only the even numbered ones. 2 pi over 12, 4 pi over 12. You can still see that each box measures a pi over 12. So pi over 12, 2 pi, 3 pi, 4 pi over 12. It's just for spacing purposes that I do this. So I don't have to reduce this. Don't try to reduce this to a pi over 6, you know, pi over 3 and all that. Just leave it the way it is, because it's going to be helpful when you begin to graph, because all your coordinates are in terms of 12. 12 pi over 12. In fact, we do have a 16 pi over 12. And on this side, this would have been a -2 pi over 12. So don't just ignore the negative side just because we're not going to graph there. Your scale must extend on both sides. And here, think about this. I'm marking it as 2, 4, -2, and -4. If you actually think about it and see what each box measures, the fact that each box measures 1 becomes clear, because this is 1, the first box is 1, then it's 2, the middle one is 3, 4, 5, 6. Again, for spacing purposes, I do have them jumping by 2. Okay, so now we have 4 pi over 12, comma 0. That's this point. Okay, red is better. 7 pi over 12 and 4. 6, and this must be 7 pi, right? 7 pi and 4. What was the next one? 10 pi over 12. 10 pi over 12 and 0. As you place the dots, you're beginning to see the pattern, so that's also good. 13 pi over 12 and -4, so that's the middle one. 13 pi and -4. And lastly, 16 pi over 12 and 0. Because I've spaced it out, it's going to be a nice wide wave pattern. Right? And that is one period here. Okay? And because of the phase shift, the phase shift tells us that we didn't start at 0 here, right? Typically we start here and then we go like that. So we didn't start at 0, we started at 4 pi over 12, which reduces to pi over 3, which was a phase shift. Then if you come back here and look at the midline, D was 0. If D is 0, the midline is your x-axis itself, meaning this is the middle line that kind of symmetrically divides your graph up and down. So if you look at the midline, it helps you to see that your, let me look at this one, yes, that your highest point was 4 and the deepest point was also 4, right? You just know that it's 4 and -4 in terms of their direction, but the highest and the deepest distance is still 4. You got that? And then you, if you again go back to our step 1, we saw that the period is pi, right? So if you, meaning for one cycle to happen, you'll have to go pi units. So we can check that here too. So we'll start here. And so I want to show it like this. I'm starting here. This is the pi over 3 mark. And we went all the way to 16 pi over 12. Okay, 16 pi over 12. And that was the one cycle that we measured. Okay. Now take this 16 pi over 12. That's the end of your cycle minus the beginning of your cycle, 4 pi over 12. So I'm trying to find the period. Okay, so we know the period. We know that the period is pi. I'm testing if that is coming back to a pi. So 16 minus 4 is 12. 12 pi over 12 equals pi. And this was the period we found here in step 1. Step 1, the period came out to be pi. And we're making sure that we are able to verify that on the graph. And the graph says that the period is also pi, your one cycle. You can see the cycle's motion here, right? It goes up and then down. So that's one full period, but you can exactly say what that measurement is because you were able to measure the distance. So we got the phase shift, meaning it didn't start at 0, it shifted and started at pi over 3. And you could see the amplitude. We saw the period. So I think we checked everything, all that we need to verify in order to make sure that all that we found in step 1 algebraically are verified graphically. Okay. And also, quick note, there was one more thing I wanted to discuss. The C over B, right? Let me take you here quickly. The C over B is a pi over 3, and that was a positive value. You didn't get a negative pi over 3, but a pi over 3, right? The C was positive. So pi over 3 positive means it shifted, the graph shifted to the right by pi over 3 units. And that, and that is also verified here because we shifted to the right pi over 3 units. So that was the last piece that I wanted to discuss to make sure that everything lines up. So we'll take a look at a cosine problem. And because we've seen, a problem with this full-fledged expression, I think we should try a problem that has the B and the C. So let's try that. Graph y equals half cosine 4x plus pi. Okay. The rules are exactly the same. You just are now computing for cosine. That's the only difference. So let's go to step 1. And before that, let's quickly write y equals a cosine bx minus c plus d. Okay. A here is half, positive half. Absolute value of a is absolute value of half. You know the maximum height, the maximum distance from the midline up and down is going to be half each. And a is equals positive half tells you that you are going to go up first, right? So you're going to start from the top. Now this is a cosine function, so you expect your graph to look like a V if it is in the standard form, if your a is positive. And if your a is negative, then it's going to be the inverted form, right? If a is negative, it would be inverted. You start from the low point, go up, and then come down low. If it's a standard form, you start from the high point, go down, and come back high. We got that. B is the coefficient of x, which is 4. C, this is interesting. So if you come back here, this part is 4x, and you need a minus because you see the minus there. You need a minus. So you're going to bring in double minus so that you get back that plus. So 4x minus a minus pi. Therefore, you can see that C stands out explicitly as minus pi. And then D is 0. This is crucial because we're going to now find our period period is 2 pi over b, which is 2 pi over 4. That comes out to be pi over 2. So that's our period. And the phase shift is c over b. C is a negative pi over b, which is 4. So this is our starting point for our points, but we also know that this means you are going to have your graph shifted to the left. And it tells you exactly how many units. It gets shifted to the left by pi over 4 units. Okay, about that. Step 2. Period over 4 is pi over 2 over the 4. It's a complex fraction. Make sure you flip the denominator and multiply it to it. So that comes out as pi over 8. Interesting. So your graph, the period is pi over 8. So this whole thing, this one period must be fitted within that pi over 8. It's going to be really compressed. You can expect that. Oh, I didn't generate the excess. X1 is always your phase shift. And in this case, the phase shift starts at negative pi over 4. That's your first point. X2 is this negative pi over 4 plus the period over 4, which is pi over 8. You're beginning to see that this pi over 8 meets the denominator 8. So negative 2 pi over 8. I'm adjusting the first fraction, right? Up and down by 2 plus pi over 8, which gives you negative pi over 8. X3 is this negative pi over 8 plus the positive pi over 8, which is from the period over 4. That gives us a 0. X4 is 0, write that again, 0 plus the pi over 8, which is pi over 8. And then X5 is pi over 8 plus this pi over 8, which is 2 pi over 8. That reduces to pi over 4. All right, you can't see the pattern so clearly right away, but it is there. I'm going to explicitly write this out for each one. That is negative pi over 4. I want to write them all in terms of 8, okay, with the denominator 8. That's negative 2 pi over 8, the first one. This is negative pi over 8. This is 0, pi over 8. This is 2 pi over 8. Now you can see the pattern, right? Actually, it's jumping by ones, but then it's starting off from the negative angles. So it is, you know, kind of symmetric about 0, right? You have 2 points on the left of 0, 2 points on the right of 0. That's why it looks like this. So your pattern is all visible and it's coming out nicely. And then step 3. Get your table. And write your function, which is y equals half cosine, what was it? 4x plus pi, in parentheses, of course, right? 4x plus pi. And then this was x comma y. Negative pi over 4, which is 2 pi over 8. I'm trying to keep them all in 8. Let's see if there's a pattern where I can, you know, simplify my calculations. So this is half cosine 4 times negative 2 pi over 8, right? So 4 times that x plus this pi. Please be very, very clear. I like to use brackets when I have, you know, additional computation inside the angle. And give it the space it needs. Don't try to squish your work. The 4 and the 8, so there's always going to be that 4 that cancels off with the 8, so there will always be a 2. I'm making a mental note of that, that I will use that pattern next time. But in this case, this 2 and the 2 will also cancel off, leaving us with negative pi there, plus a pi. Oops, write that pi neatly. So these two will cancel off, leaving us with half cosine 0. You know cosine 0 is 1, so half times 1 is half. Okay. Next one is negative pi over 8, which is half cosine. Remember I told you about the 4 canceling with the 8. That's the pattern that's going to happen every time because I'm keeping it as 8. Oh, oops, I'm losing one note. Oh, good. Well, we did lose a few steps here. Not so bad. Cosine 0, and that was half. Negative pi over 8 is going to be this half cosine negative pi over 2, because the 4 and the 8 will cancel, so I'm keeping it as a 2 plus pi, and that's half cosine. Again, do all these things as mentally as possible because these are simple fractions. So that's going to be 2 pi minus pi, which is pi over 2. Cosine pi over 2 is half times 0, which is 0. And this is again making sense because your cosine will start at the top and then go down, right? So it's starting at the maximum point. And your maximum point is your A, your amplitude, which is half. So that's nice. It's starting at half and then it's going down to 0. And then it has to now go down to negative half because that's the lowest point. Let's see if that happens. The third point, the third x value is 0. Half cosine 4x, right? So 4 times 0 plus pi, which is half cosine pi. Cosine pi is a negative 1. And as we expected, that's a negative half there. And then we have pi over 8, half cosine. It's the 8, the 4 and the 8 will cancel, so I'm going to write it as pi over 2 plus pi, which is half cosine 3 pi over 2, isn't it? 3 pi over 2 is the 270-degree mark. So half times 0, it's 0. One more. 2 pi over 8. So half cosine 2 pi over 2 is what I will write. And then I have the pi's, the 2's canceling off. So half cosine 2 pi is what you get out of it, which is half times 1, which is a half. All right, so let's write the coordinates now. And as you write the coordinates, you will begin to see the pattern very, very clearly. Negative pi over 8, comma 0, 0, comma negative half, pi over 8, comma 0, and lastly 2 pi over 8, comma half. And once again, you want to draw your own grid because your denominator is now 8, and it'll be nice for you to see your own grid. So let's get that graph done. So my grid in this case, I would need it to be like, in the middle, the y-axis, because I do have negative angles as well. So I have 2 pi over 8, 4 pi over 8, 6 pi over 8 this side, negative 2 pi over 8, negative 4 pi over 8. As again, always watch what the unit is for each box, each square here, right? So this first square is a pi over 8, so this will be 2 pi over 8, 3 pi over 8, 4 pi over 8, and so on. And this is 1, 2, 3 here, negative 1, negative 2, and negative 3. If you watch carefully again, Here, each box actually measures a half because it's half, then 1, 1.5, 2, 2.5, 3, and so on. So I needed the half because my coordinate goes up half and down half. And so it makes sense to have that. Okay, let's get our coordinates. Negative pi over 4. Negative, where were we? 4 pi, negative 4 pi over 8. Oh, I'm sorry, negative 2 pi over 8. Negative 2 pi over 8 and half. Okay, got that now. Negative 2 pi over 8 and half. That's this point. Right? Then it's negative pi over 8 and 0. So negative pi over 8 is this mark, that and 0. Then it's 0 and a negative half. So 0 and negative half. So it's over here. Pi over 8 and 0. And then it's 2 pi over 8 and half. You can see the V pattern. We expect that. Okay. Oh. If it's too close, it's just not working for me. Okay. So that looks strange, but it is that wave pattern, because if you are not sure, if you stretched it out, you will begin to see that pattern going through. Well, this is one period, so we need to, of course, check if this is all the stuff that we wanted to graph. So that's 4x plus pi. It looks complex, but look at the graph, it looks so tiny. All right, so now look at the highest point. The highest point is half, and the lowest point is also half. So your amplitude is the maximum height or the minimum height. So that's going to be, came out to be half, so that is good. What about our phase shift? Our phase shift says that, here it said, let's go to, yeah, that we got the graph shifted to the left by pi over 4 units. Is that the case? Well, if you look at this, let me use a different color. This distance, that distance is actually pi over 4. So this dot should have been here because that's where we start, right? We saw the characteristic of a cosine function. It's always on the maximum point on the y-axis. So this should have been here, and then you should have had that V pattern here. But this dot was moved to the left here, right? This dot is moved to the left. And by how many units? By pi over 4 units. So phase shift gave us negative pi over 4, indicating the shift to the left. We got that. And then let's check the period. The period is starting here, and it goes all the way up to here, right? Look at the end of the period, which is 2 pi over 8 minus the starting point of your period, which is a negative 2 pi over 8. Remember, it's 2 pi over 8 minus another negative 2 pi over 8. Yeah? And so that's 2 pi over 8 plus 2 pi over 8, which is 4 pi over 8. That reduces to a pi over 2. The period is pi over 2. Come back here. Period was pi over 2. That is matching again with your step 1. Again, as I mentioned, what you do here algebraically, you get to test here graphically in the end. And then you're convinced that your graph is right. You got all the points, all the positions are all correct. And even though there is this pattern and everything to verify that you did it right, you want to ultimately make sure that all the other parts, A, B, C, D, they all work together and it's all working fine. So that's pretty much it. If I had, for instance, if I had this function plus 3, you would move this entire thing up 3 units, right? And so each one would move up 3 units. And that's how you'll know that you have shifted it up and so on. Yeah. So with that, we wind up with this section, and we'll see you in the next video where we'll talk about 6.2. Thank you, class.